Hi, everybody, and welcome to the NSGIC 3D Hydrography Program for the Nation. This is our monthly forum, and we're excited to have Kyle Onda with us. He's going to be talking about the Internet of Water. I know we've all heard a lot about it, and Kyle's going to kind of fill us in. Of course, as usual, just want to give you a little bit of an update on where we are as a project. Most of you know that we are a cooperative agreement between NSGIC and the USGS, cooperative agreement to engage state and local governments and their private sector partners in the development of the 3DHP data product. And these are our tasks on the right. We're going to run through them. One is to facilitate information webinars, and here you are. This is the monthly forum. Please note that all of the most current 3DHP forums are the recordings, the PowerPoints, and the Q&A documents are available at the NSGIC knowledge base. This is part of our new website implementation. So be sure to go there if you want to want to watch a recording or see the actual slides. And Phil's going to stick some URLs in the chat for us. That was slide 3. There we go. Okay. Well, you're ahead of me now, Phil. Did you get the form? We're good.
Yeah.
It's all good.
I got
okay. That sounds good. So we're supposed to establish communities at mynsgic.org. Of course, we have the 3DHP FTN interest group. That meeting gathers in place of this forum about 3 to 4 times a year. And we have the hydrography stewards community. And again, that's not limited to national NHD stewards. It's anyone in your state that takes a key role in developing hydrography data. If you have people in your state that should be part of this group, please be sure to get this URL to them where they can fill out the form. And also, glad to report, let me look, not sure if Josh is on the call, but I did see Jane is on the call. Thanks to Josh and Jane for putting together some meeting notes from their meeting that was held at the NSGIC. Jane, is there anything you'd like to comment on that? Sorry to put you on the
Sure.
spot.
Yeah, no problem. I've been emailing with Josh. We're trying to pick a date for a meeting to follow up on this, and so we're looking at early October at this point. So stay tuned.
Okay, great.
Yeah. Thanks.
But you can go to the library section of the hydrography stewards community if you want to get the notes from the gathering at the NSGIC. Again, continuing with those communities, we did want to let you know that at the NSGIC annual meeting, most of you are aware we'll be having the 3DHP workshop. It's going to focus on practical measures for 3DHP preparation. That'll be Monday morning of the conference week from 8 to 10:30. It is in person only. So please, if you plan on attending, please register. We're doing some special activities and stuff, and we need to know if you're going to be there so we can adequately plan for your participation. And that also includes getting a room large enough. So please register. If you're going to be at the conference, we'd love to see you there. In addition, we'll be having a 3DHP for the Nation interest group breakfast. That'll serve as our quarterly meeting. And not sure which morning that will be. That'll be aligned with the final program. Whenever there's going to be 3DHP activities in the program, they'll usually align the breakfast meeting on that same day. And if you're going to be presenting at the conference on a 3DHP related topic, let us know. We'd like to share that with the community to make sure that they know that that is out there as well. And Phil, were you able to put that registration link?
Yep.
Oh, I guess I'm not. Oh, I'm not keeping up. You are, and I'm not. Okay. Great job. Thank you. We continue to maintain an inventory of state and regional 3DHP experiences. Phil's actually doing some work with that right now, mapping it to some of the business cases that came out of, correct me on the study name, Phil, requirements and benefits analysis?
The hydro requirements and benefits analysis in 2016.
Thank you. So additional tasks that we're working on to support 3DH implementation. Most of you know we've developed a set of critical factors. We'll hope to revisit that later in the year. We've got guidance documents in development. We're working on culvert mapping techniques, attributes, and data applications. So we've got a good practices document in development. And we are, as I said, we're having a workshop next month, and we are looking at 3DHP planning and preparation. And we have a survey out, and we really need your input, whether you're state government, whether you're local government, whether you're private sector. We want your input. You don't have to coordinate responses from a single state, and you don't have to attend the workshop. This is just to get information from you about what you are doing or what you would like to be doing in preparing for 3DHP. We will use those results to sort of shape the workshop and guide some discussions there. And then the results from both the workshop and the survey will be put in some sort of a quick sheet, handy dandy guide for things you can do to start preparing for 3DHP. And Phil's got that link in the chat as well. So thank you very much. All of these resources are available from the 3DHP for the Nation Hub, which is our other task, is to create and manage the hub. And you can access all of those resources through the hub. And we also, again, work with USGS and through Dennis Peterson from Tennessee, the Federal 3DHP Working Group. Dennis is the NSGIC liaison to that working group. Any questions about project activities, what we've been up to, how you can engage? All right, then. With that, we'll get to the purpose for today. I'd like to introduce Kyle Onda, Dr. Kyle Onda. He is Director of the Internet of Water Initiative, Center for Geospatial Solutions at the Lincoln Institute of Land Policy. Kyle, I will stop sharing and you can bring your slides up.
Sounds good. Thanks all for having me. Let's fire this up. Okay, so I'm going to give an overview of kind of what the Internet of Water means to me. I'll go over kind of our big vision and then sort of institutionally where we're situated and how you might engage with us, and then more into the nitty-gritty of what we're trying to do. So, why Internet of Water? I'm sure this audience is probably no stranger to this sort of thing, but we have an increasing number of web applications that are providing open data, but open doesn't mean interoperable or even discoverable. It can be pretty hard to find, right? If you were to Google water data for a location or a city in the US, you kind of get a grab bag of results, most of it from USGS administered systems, and it's not all going to be kind of nicely formatted. Whereas if you look at for more traditional kind of commercially available information like movie times or recipes with ingredients or restaurants in your area or even just the weather, it's much easier to find and better organized from the get-go. And we think water data should be this should be possible for water data, right? Like the sort of vision here is if you were to do that Google search or any search engine, you should get information that's structured and interlinked with other relevant data, topically organized, spatially indexed, and it shouldn't require specific specialized knowledge ahead of time of which agencies would be collecting data in your area. That's really what we want to happen. So, Internet of Water, what is it? At a very high level, it's this general vision of what I just said, of this modern water data infrastructure that makes data discoverable, accessible, and interoperable across the United States. It's also a formal coalition of organizations and public agency liaisons that are providing technology research development and then socialization of the necessary data practices to enable this vision. So the coalition has a steering committee, which right now is composed of representatives from the Western States Water Council, Duke University, where the project was initially incubated, the Water Data Collaborative, which is a community science membership organization, Kawazi, the consortium of universities for the advancement of hydrologic science incorporated, and my shop, the Center for Geospatial Solutions at the Lincoln Institute. Sort of below that steering committee level, there's also a broader community of people implementing these ideas. We have lots of members from state agencies, federal agencies, and then the steering committee members themselves. And sometimes there's specific funded projects, and the main projects that are kind of funded but implemented by my shop are GeoConnect and the Network Link Data Index, both of which have support both in kind and financial from USGS. So shifting a little bit to 3DHP, but still aligning with the Internet of Water vision, is we want data providers to be able to unambiguously link their data to 3DHP features, those hydrologic features, and publish metadata on the web about them. And we want data users to be able to query for hydrologically relevant data sets. All right, so data sets that are hydrologically relevant to points or areas of interest to them to answer whatever question they need across all contributing organizations, right? Across all organizations that might be using 3DHP or previous hydrography products. So here's sort of a sketch of a vision we'd like to happen, right? Someone wants all real-time historical and forecast data that's hydrologically relevant to this point from the past 30 days on precipitation, diversion, stream flow, and groundwater pumping. Right? How do we want that? So the way we envision that happening is being able to call first a network link data index to say, find all the diversion points downstream and all quantity and quality monitoring locations upstream, including tributaries. And from those, we'd like to get, so from one data system that comes from all one place, like the diversion sites, that might all come from one data system, like the Western States Water Council water data exchange. But what about all the information upstream that's not about diversions? For that, we would want to go to another search index where we could look at each and every one of these sites and see where the data lives about that site. And so be able to query, say, federal and state data services and pull in their data. So how do we try to get people to do what needs to happen to get there? So the Internet of Water Coalition has biannual coalition-wide meetings to discuss overall governance and strategic direction, as well as more specific working groups. Two of the more active examples right now are a public agencies working group who discuss things like funding and procurement strategies, socializing open data, and water data standardization processes to peer agencies and things like that. And then a technical working group that's surrounding GeoConnects, which I'll describe more later, which focuses on standards, use case development, and prioritizing my shop's efforts for software and data development. So some specific now moving to some specific technologies that we at the Center for Geospatial Solutions are doing to help realize the Internet of Water. I'll go into the open source water data exchange tools, the Network Link Data Index, and GeoConnects. So we leverage a lot of open source, both software and data standards coming from organizations like the OGC, Open Geospatial Consortium, to help folks take data from whatever format they need and be able to publish it on the internet in a standard format. So in an example, we have a lot of Python tooling that helps people write transformers from any source data, put it into a standardized database with a standardized API on top. In this case, it's the same API pattern that USGS is using on the next generation instantaneous value service, and then publishes that data in a variety of formats, including to a GUI or data visualization, and to the GeoConnect system, which again will make sense in a bit. So the idea there is anyone who's taking data off data loggers can get their data published online and have that data be usable in the exact same manner by the exact same clients as USGS stream gauge data. So the second thing we work on is the network link data index. This is a publicly accessible API for upstream downstream query. So you can give this, say, a latitude and longitude and ask for everything upstream tributaries or the main stem, downstream the main stem and diversions, and select items that are contributed from various organizations. So in this example, we are looking for everything upstream and downstream from a collection of New Mexico state water data agencies, from NWIS, and then from the Water Data Exchange, meaning sort of points of diversion for water rights administration purposes. Currently, this software is built on NHD plus v2, but HR and then 3DHP, of course, will be in the pipeline. And this software is open source, so the software itself is open source. An instance is run at the USGS, and anyone is welcome to publish metadata to that, to index their data to this, so that other people can discover your data in this way. And since the software is open source, you can also, your institutions can run it on your own for any backend tooling that might be good for you. This is just demonstrating that it is in fact live and operational. So the Water Data Exchange has their own application with their own data, but they call the NLDI to bring in Water Quality Portal and USGS NWIS data in the context of their own monitoring locations. So that was the Network Link Data Index. Now I'll move to the GeoConnect system. So the GeoConnect system is a standards-based framework both to publish and then to discover water data. This is how we want to get to that vision of the well-organized data that even search engines can construct interesting information products out of. And the way we do this is we ask people to use standards to publish their water, particularly their water metadata, on the World Wide Web. And in particular, the kind of metadata, structured metadata, to reference their information to a standard hydrography network. So this is sort of what's going on under the hood. Just a basic illustration of what's going on here is, in this case, there's a website. This one represents a dam somewhere. And the structured metadata about that dam says that it's on a particular, say, reach code. And it's connected to a bunch of other data sets through that reach code that way. And it's also represented in a particular data set that's maybe about a lot of hydropower dams. And so these are all the other dams in that data set. And so there's lots of very, very complex relationships that become possible when people are publishing their metadata on the internet in a reasonably structured way. Just to drive the point home, right? We want to do this without centralizing data governance and storage. So what's going on here, right? So imagine a situation where we have a real world location of interest, like a dam, and maybe this stream segment upstream of it. So we know these two things are hydrologically related, but two different organizations, right, are monitoring them differently. The Army Corps might have observed and modeled data about the dam operations, and a state or federal agency might have a stream gauge, right? And of course, there's lots of other more complex hydrologic relationships as you move up and downstream of both of these things. And so really what GeoConnex is trying to do is enable computers to infer and leverage relationships between data where the data themselves are not aware of each other. So the problem is, on their own, feature identifiers are ambiguous and difficult to parse, right? So I have here a dummy data set about some monitoring locations, right, that have IDs and names, and there's a spring and two stream sites, and they have latitudes and longitudes. And then their hydrographic reference is a reach identifier, right? But how does a machine interpret this in the context of other data, right? So what hydrography data set is this? You don't know. Is there supposed to be a leading zero? It looks like there might be. It's kind of hard to interpret. Would we be getting the wrong reach? And then there's nothing particularly contextual or informative about the IDs themselves for a human analyst to know without pulling down the hydrography data set itself and merging it in. So it's hard to tell if these are hydrologically related. What we're trying to do with the Internet of Water is have a framework to resolve this problem using persistent HTTP identifiers, which means basically, instead of merely having sort of integer digits or human readable names identify things, because human readable names are also ambiguous. Many people don't know there's 2 Colorado rivers in the US. We have unambiguous HTTP identifiers. They're good for disambiguating things, and they're also good because they point to exactly what we're talking about. Basically, DOIs for real-world hydrologic features. So what we're hoping is that 3DHP will be published with unambiguous URL formatted feature-level identifiers for the stream segments, the main stem rivers, and then sort of the events, right? The dams, the gauges, and so on. So to show you what I'm talking about as an example, right, here's a URL for Hoover Dam, right? And I'll just smooth this over, right? So you see I click this link and it directs to a website which is about that dam, Hoover Boulder. And so the idea is, if you put this in your data set, it's very clear what it's about. It's about what's described at this website. Hoover Boulder Dam, it has links to other data sets that describe this, like the National Inventory of Dams. And it has a GeoJSON representation, meaning that you can actually pop this identifier into something like ArcGIS Pro, and it will just resolve the GeoJSON and pull in the reference feature. So that's super useful for automated workflows, where someone has published a data set using these identifiers. And more importantly, the hydrographic identifiers, like, say, the main stems, right? It becomes very easy to pull in the hydrologic context for whatever data is using those identifiers. Moving on. So those are just reference features, right? Those are things that we want you to tag your data with, right, as a way to reference your data to hydrography products. But you can also then structure your metadata so that it itself is published online and other people can reference your data. So in this example, right, you have the well-known, new style USGS stream gauge pages. And what we're doing at the Internet of Water is coming up with structured metadata formats that are embedded in here that standardize things as innocuous as the name, but also how we specify latitude and longitude, and how you specify, where on a hydrography product it's located. And multiple organizations can do this. So the USGS can do it, the state agencies can do it, they can use different web frameworks. They don't have to export to the same data format. But if they're embedding the metadata on the website in the same way, it's machine interpretable that, put it this way, right? So the USGS could have their own special metadata and it says, I'm a stream gauge. It can have a hydrologic reference that says, I'm on the Rio Grande. It can also have more contextual information, like I'm operated by USGS and I have data on stage discharge and temperature, and it can have a link from where to download the data. And then the state agency, right, could use a similar format so that a machine can understand that this site is an irrigation diversion sensor on a different river, operated by a different organization, but that it has discharge data. This might sound like a huge lift, but what we're talking about here is basically the same kind of search engine optimization that goes on all the time on the commercial internet. Our view is if restaurants and gas stations can do this, well, water data providers should be able to as well. So how is this working? So we talk a lot with the data user community, and we, in the Internet of Water Coalition working groups and USGS, develop metadata standards guidance, authoring guidance, which we help data publishers implement, so publish their information on the web, which then lets an indexer like us for now, but maybe commercial search engines in the future, to index their data, their metadata, and deliver it to the data user community in a usable format. And 3DHP really provides this important backbone, right? These feature identifiers, right? Well, the features themselves are also super important, right? We finally have highly accurate 3D hydrography. But if those features are published with a high degree of specificity on the web with URL identifiers, that's what allows them to be sort of incorporated into our authoring guidance. We can say, use this identifier to tag your data. And that allows data publishers to unambiguously say their data is on such and such river. And then it allows eventual data users to make queries like, give me everything on that river. So we're setting up the infrastructure to do this. The Quasi HydroShare has a pilot project that calls our API of reference features. So when someone wants to publish data using the Quasi HydroShare platform, one of the things they can do is search through the kinds of reference feature identifiers we have that are spatially relevant to the data set they uploaded. So in this case, it's sort of highlighting in orange all of the HUC 10s that are in the spatial extent of their own data set. And then they can pick and choose which ones their data set is relevant to. And then HydroShare publishes this data set on the web with that appropriate structured metadata. So future researchers can find data that already exists from multiple data publishers about a given feature of interest. The USGS itself just recently did this with the new instantaneous value service in the Sensor Things API. So you can query that API by main stem river identifiers. And so then it's possible to, within like 3 lines of code, pull down the latest discharge readings from the gauges about specific rivers, right? Not spatial extents, not HUCs, not reach codes, but specific named rivers, right? And so this is a useful function that wasn't available before. So I have a lot of further reading here. I'm sure that will be made available in the presentation. And I'll stop there. I know I took less than the allotted time, so I'm happy to go into plenty of other detail if people are interested.
Thank you very much, Kyle. Interesting. I'm going to ask folks to put any questions they have into the chat, please. And I've got a few questions, so I'll start with one. First of all, from the beginning of your presentation, what if one of our participants was interested in engaging with your Internet of Water Public Agencies Working Group? Is that an open group? How would they do that?
Yeah, that's an open group. I would just start by contacting this email address. We're always looking for more members.
Capture that. So Phil's got a question. It kind of goes, how are the URLs to the elements generated? I think that kind of goes back to, well, can you talk a little bit more about that?
Right. So this is still I'm not part of the 3DHP governance in any way, but basically we have a persistent identifier registry similar to the DOI, but ours is free, where there will be a namespace for 3DHP. And so basically what will happen is I'm typing something in here into the chat, is they can create a namespace at the geoconnects.us registry. That's something that will be like 3DHP. So I've just put that in the chat, and then it's like a math equation. So then there will be 3DHP, / reach codes, and then whatever the reach code ID scheme is. And so they can mint that identifier with us and then declare where should that URL go. And that might go initially to, say, an Esri REST service call for that identifier. So it will just direct to the JSON representation of that identifier. But it can be redirected anywhere. But the process of minting identifiers is really just in an open public registry, which is actually just described if you just go to the geoconnects.us top level URL.
All right, and bear with me here. So is the understanding if they go to these links that it'll direct user to the author of the associated identifier?
So, right, so I want to be clear, the 3DHP namespace isn't minted yet. We do have NHD
Right.
plus version 2 in there. And so I think best practices, so where the specific identifiers go is to is supposed to go to a web resource that describes what that identifier identifies, right? So in this example, right, with the Colorado River, or here's a good example. I have an NHD plus v2 comment in here, right? So in this case, it's just going to a USGS JSON representation of that reach code flow line. But it's really up to the organization minting the identifiers to determine what the resource looks like when it gets pointed there.
All right, let's go on to Brian asks, how are you going to add in wetland maps and private water wells?
So wetlands is an open question. I think we would like to collaborate with Fish and Wildlife who do the National Wetlands Inventory. They currently don't have an ID scheme for individual wetland features. It's almost more of a raster data set almost, in that the identifiers are sort of wetland classes. and the vector feature identifiers are just sort of the object ID that ArcGIS Pro spit out probably. So we need to work with them on that, but that's fundamentally how they would be added. Is we need individual sort of wetland polygons to be published with individual HTTP identifiers. As for referencing them to the hydrography, I mean, I think that's part of, we're not really interfering with how people index stuff to the 3D HP flow lines necessarily. But we do want them to, once they've made a determination that something is indexed, to do so using identifiers. And private water wells, well, the nature of this system is that it's open and public, so sort of restricted information should not be contributed to the GeoConnect system. However, for internal use, water wells could, for example, mint identifiers that direct to a web page which has authentication in front of it. So they wouldn't go anywhere for people who don't have the password or the token. But we have plenty of, we are planning to add a reference layer of all the wells. We don't have them in there yet, but we have like the dams, and we have like all known surface water monitoring locations. And so we're going to try to get wells in there as well.
Okay. Matt asked, are you addressing surface water only or also subsurface, such as aquifers?
Yeah, we're doing aquifers too. So right now we only have like 2D representations of like the USGS principal and secondary aquifer systems. But all of these do have individual identifiers. And I'm open to talking with folks more in the know about a good way to get at those, particularly the 3D aquifer representations or best estimates of them identified and in the system, so that people can then tag their data, right? Tag their monitoring wells, which aquifer they're related to.
Phil asked, will USGS mint the identifiers when the EDH data is accepted into 3D-HP? That may be more a Sue question. Do you have insights? I'll go to Kyle first.
Right. So, like all NHD Plus version 2 and NHD Plus HR identifiers that are currently in the system were minted by USGS staff, so I don't expect that to change.
Okay.
And this is a Sylvia question. I think Sylvia's on.
Yes, that is correct. We'll be minting those as data is ingested into 3D-HP. All the main stems are being identified now and will become part of the data model. So every stream will have a main stem identifier associated with them.
Right. So how would the approach work with the? So,
let's get this on the audio. Let me go ahead and read this question. How would this approach work if the baseline hydrography data is updated and features reaches are split? And how would features be associated if data is collected on a reach that is not yet represented in the hydrography data set? In other words, a reach that comes up in NHD that isn't represented in NHD version 2, that's in the high res but not version 2. There's a question.
Right. So eventually, I think so. Part of this question is relying more on the main stems construct. Is once we have a backbone that's fairly high resolution of main stems in 3D-HP, we can kind of relate other versions, right? All of the reaches from other previous hydrography data sets to those main stems. And we can do that on the back end. So we'll maintain identifiers for previous versions of hydrography and then maintain in our knowledge graph database the relationships between those reaches and, you know, the 3DHP main stems. So people are free to use older identifiers, and then they'll be associated as appropriate. Is the basic idea.
Yeah, I'll just add that you can you can what Kyle was saying, but you can specify which version of the data you're using, so it should be able to resolve that pretty easily. And once 3DHP is available, that should have even more main stems than we have now. A lot more, actually. So.
All right, I'm going to encourage folks, any last questions, add them into the chat. Kyle, you touched on these, but can you talk a little bit more about how there'll be a, you talked about the metadata elements, the custom metadata elements. Is there going to be a registry, or how will people, you know, contribute and or contribute effectively into that?
Right. So that's the beauty of it is, so I'll just show. So the registry is currently administered on GitHub. We might migrate off GitHub to a more user-friendly interface at some point. But just to show you what's going on, right, so people basically, you can submit a CSV which basically just says, this is my identifier. So in this case, this was an organization in California that was doing a stream gauge catalog. So this is their HTTP identifier, and this is where they want it to go. So that's all you have to do is submit it there. And that tells us to go collect the metadata that is coming, that is made available at the web page that the URL points to. So then so basically it's a matter of putting metadata in websites about your, you know, locations of interest, and then minting persistent identifiers with us, and then we'll have the list. Okay, Ben, our software developer, is in the chat and helpfully reminded me that this is sort of the active registry at this URL he put in. So, for example, USGS has the complete list of groundwater and surface water sites that you can sort of navigate through. And so if you contribute to that GitHub repository, your sites will end up in a registry like this.
Thank you very much. And then one last question. Will the US, and maybe this is to you, Sylvia, will USGS mint the identifiers when EDH data is accepted into 3DHP? Oh, wait. Is that your early? Yeah, you've already asked. Never mind.
Yeah.
I'm having, go ahead.
I'll just add one thing from what I said earlier. So initially, all of the main stems will be based on NHD. So the NHD density of network is basically what you'd be seeing the main stems on. But as EDH data is accepted into the 3DHP, you know, that replaces what the NHD source with the EDH source. And new main stems will be assigned to all of the reaches within, or not reaches, sorry, I'll stay away from that word, but all of the segments within the new data as well. So we'll just be growing those features that have main stem IDs and correcting sections of main stems that are being replaced with EDH as well. But the main stem ID won't change, but the features that represent it will within 3DHP.
Okay, and I guess they'll ask, Will states with events linked to legacy medium resolution be able to easily link their data into the new minted mainstreams?
Yeah, I think that's yeah. So if you tag data with NHD plus version 2 reach codes or common identifiers, I think both of those will have stable mappings to the main stems that are in the 3DHP backbone. So I think at the very worst there will be some lookup table, and at the best it might be fully automated if you participate in the GeoConnect system.
All right, last call for questions. Nope, great presentation is all we're getting at this point. So thank you very much. Kyle, appreciate you joining us here today and kind of cluing us into how this valuable resource is going to integrate with 3DHP. And thanks as always to USGS and Sylvia and Sue and Steve for keeping us informed as well. I'm going to grab the screen back real fast. As you all are aware, the forum is held the third Wednesday of the month, 3 to 4:30. And next, we will not be having the September forum. We hope to see you at the NSGIC annual meeting, at the 3DHP for the Nation breakfast, among other activities. If you have information or activities you'd like to share through the forum, please contact me directly, or you can contact Phil, our project engineer, as well. And with that said, I will take any last questions, comments, or suggestions. All right, then. Thank you, and thank you especially, Dr. Onda, for joining us today and sharing this information. Appreciate it.